Good morning.
Good morning, Secretary Wright. Thank you so much for joining us. Let's start at the top. It seems to me that you have a new strategy at Department of Energy. You have put fusion from day one in your points, in your public posture, in your social media. Can you tell us why fusion, why now?
Fusion matters, and it could matter massively if we successfully deliver on it. Yeah, we just released, I think it'll be on the website earlier today, the DOE Fusion Science and Technology Roadmap. Took me longer than I had hoped to get my fabulous Undersecretary of Science, Dario Gil, who's here today, and he'll speak in more detail later. But we wanted to design an effort that's synergistic with commercial efforts, not competitive. If they're building a big tokamak, we don't want to build the same big tokamak. We want to do what is it that we can add to commercial efforts to speed the realization of the promise of fusion, which I think is gigantic. I worked on it 40 years ago. It isn't that we've gotten nowhere in 40 years. It's just a hard problem to replicate the sun on Earth.
You're not new to fusion, sir. You've studied this in your undergrad studies. What was 30 years away, fusion moment? Why do you think it's now here?
So, I mean, the nerdy technical reason is the Lawson criterion we've been able to achieve has continually gone up. We've made progress over the last 40 years, and we're about there. The maybe more honest reason is we're just at a different place today. Number one, we have AI, which I think will be a tremendous enabling technology for fusion. And then the development of fusion will be an enabling technology for supercharging the growth of AI. We're also at a place where it's not just research in labs, slowly funded and chosen in a couple efforts, but we have commercial money in the game. Lots of different efforts, trying different approach, different technologies. Commercial money's less patient. It's driving hard, it's made great progress. And maybe a third reason is China. China has had massive investments since our NIF breakthrough and maybe since a few years before that. From 2019 to today, China has spent maybe close to $10 billion on fusion. And they're not as open and sharing of what they're doing. And so we have reason to be concerned about that. It is important. I think it's good for the world if the United States is the leader in fusion.
When we spoke at the AI Expo, sir, we had a great conversation about the role of our labs. And you mentioned the ignition that happened at our Lawrence Livermore facility was a breakthrough moment. Can you talk a little bit about the role that labs have played in over the years is really putting and not losing sight of the promise of the fusion energy?
Yeah, the labs, again, since I was a kid, I never went into the labs, but if you loved big science, if you loved telescopes or accelerators or nuclear physics, the stuff you read about most often happened at our national labs, 17 of them spread across the country. And fusion's no different. You know, that 3 years ago now at Lawrence Livermore National Lab, this NIF, National Ignition Facility, first got a Q greater than 1, just at the target, not at the wall plug, but at the target. That greater than 1 is now over 4. That, I think, brought some confidence and brought some money into inertial confinement fusion, in addition to magnetic confinement fusion. There's a number of commercial entities there with different approaches. Laser technology continues to grow rapidly. Like, I think we're going to see commercial facilities with much more energy on target at NIF, but they'll be smaller. But they're built and they're possible because of the insights, the breakthroughs of what we saw at NIF.
Right. You mentioned China. Obviously, sir, it goes without saying that they are a serious competitor in this space. They've invested. They're building massive infrastructure projects. They have talented individuals, much more, a bigger number of graduate students in these kind of technology areas than we do. How do you assess Chinese efforts so far? Where do you think, how far they have come?
I think the Chinese efforts are serious. You know, they have 4 separate centers. They spent, again, probably close to $10 billion, major facilities under construction right now. They've got top scientific talent. So I think China's serious and moving fast. What China doesn't have is the commercial sector we have. We have billions of dollars of private money in different companies backing different strategies with different biases. We're going to naturally get a broader choice. I was at the Princeton Plasma Fusion Center just a few weeks ago, so another DOE lab, very early mover in building tokamaks, and a growing student population there, PhD students, postdocs, and one of their big questions that they asked to me as a lifelong entrepreneur is, should I stay in research at the labs or should I go to a commercial company? And of course the answer is it depends. You know, what you want to do, what your personality is, what your talents are, but that's a great sign that we have more students excited about it, they can see it's coming, and we need both. Right. We need the commercial efforts, but we need the labs. You know, fundamentally, we're about to start producing a lot of very high energy neutrons. Well, you got to have materials that can survive very high energy neutrons, but you don't get a lot of very high energy neutrons until you start creating fusion reactions. So I think that's just one area where we can work together. You know, every company out there that's doing something has to have a material design that can both absorb the energy from these high energy neutrons and materials that'll survive them. That's a great national lab problem, just survivability of materials and designing materials that have different survivability characteristics, and then share that with the commercial space, whether you're doing magnetic confinement or inertial confinement, for all the different companies to share some of these basic insights we'll develop.
Yeah. To pull a thread on that, sir, what do you think we need or DOE has to do to accelerate that? What's something that it's serving as an obstacle to move from the labs to the grid?
So right now, one of our challenges is funding, right? You know, I'm new to government, but when I come into government, we collect $1 in taxes and we spend $1.30 or $1.40. Like, clearly you can't keep doing that, right? That's in the short run, you can scuttle by, you know, people want to buy the US government debt, but that is a train wreck in the long run. So one of my goals and the Trump administration's goals was we have to shrink our expenditures. We focused on corporate subsidies. In the next 10 years, we had around $1 trillion of energy-related subsidies into businesses, mostly for existing technologies. Like, we gotta stop spending that money. But then when you arrive in that mindset, and we're looking everywhere to cut unnecessary things for the government, of course, to an average budgeting person, you gotta cut 30 or 40% off everything. And I've had the political challenge to sell not everything. In fact, there's things we spend money on today that we should spend more on, not less on, even though we have a big budget deficit. And basic fundamental science is absolutely one of those. You know, who's going to do the basic science of material survivability? Who's going to try to understand what dark matter is and dark energy is? So I am passionate about the critical nature of our national labs, and investment in those. We have to decide that government has finite resources. We need to spend less on some things, and those have to be bigger numbers, and more on other things. But our three big efforts in the broader science area is AI. That one's got great traction. We have massive commercial dollars in it. We have great ability for synergy there to scoop some of that private money in partnership with our labs. But the next two are earlier on than AI, fusion and quantum. Quantum sensing, quantum computing. But I think all three of these truly are absolutely transformative technologies. I could not be more excited for the times we live in right now. Think of emerging scientists right now. We have just three world-changing technologies that are just emerging. But fusion is nowhere near the scale of AI today, but my God, the upside of it is just, it's hard to imagine. So we need to continue to bring confidence and private money into it, but we need to bring more government money into it. We've been spending it at sort of a low-level research effort. China's government expenditures on fusion are way beyond ours. So in a budget-cutting time, I and everyone in this room have to help sell our people in the House and Senate. They appropriate the funds that we need to invest more, much more than we've currently been spending in fusion and quantum.
No, you're absolutely right, sir. And you know, in the last 14 months since we organized this commission, under the leadership of Senator Cantwell and Senator Rich, you
Yes.
can see movements on the Hill regarding understanding fusion, why is it important, why we need to spend more. There's a fusion caucus also on the Hill, so there's energy behind fusion, no pun intended. But I think we're getting there in terms of understanding why exactly this energy is one of the pathways towards a better future when it comes to clean energy, securing our nation, empowering our AI actually going forward.
Yeah, to follow up on that, we need to make a cell. It's urgent, it matters, but as you just say, it's a great cell. I've never talked to anyone and laid out what fusion is and what it can mean, and they said, I don't really care about that. That doesn't matter. It is a great cell, but things don't just happen. We have to make them happen in this cell. One of the ways I lay it out, today we have about 1 billion people that live like us, right? That wear clothes made out of hydrocarbons. We got light switches and we travel around with motorized transport. We get to go to technical conferences. We work on cool research. It's pretty awesome. But that's 1 billion people. There's 7 billion other people on the planet that want to live like us, desperately want to live like us. And in a real world, in a continually economically growing world, they will. We consume 5 times more energy per person than they do. It's just simple math. We need massively more energy to make the world a better place, to make it a safer place, in fact, to make it a cleaner place. If you go to wealthy countries, in the United States, the air quality has gotten better my whole life. I grew up in Denver, Colorado. We had a terrible brown cloud. Now we get to see beautiful mountains, even though the population grew 4-fold. That's what wealth brings: longer, healthier lives, cleaner environments. We need more energy. The recent fashion, the last 5 or 10 years, has been a belief that wind and solar, and it's affirmed with batteries, that this was going to transform the global energy system. Roughly $5 trillion over the last 20 years has been invested in wind, solar, and batteries. And last year, it delivered 2.6% of global primary energy. 1.2 for solar, 1.4 for wind. 2.6%, $5 trillion. And relatively low value energy. It's only in one sector, electricity, and you're not sure when you're going to get it and when you're not going to get it. That is not a way that's going to transform the energy in the world. That's not a way that's going to drive AI to just unheard of levels. Fusion could. Fusion, we think of it for electricity, and that's our first application for it. But when you generate these high energy neutrons and get absorbed in a blanket, we're going to generate high temperature flowing fluid. We can convert that into electricity, which is awesome, but we can also use it for process heat. We can do everything with it. We can do it in a small amount of land, and we can scale it up to massive scale. If you want to transform our world, our economy, and the quality of life of 7 billion people, fusion can play a major role in that. Where we've spent massive amounts of money before is never going to play, just because the physics don't work, it's not going to play a meaningful role in it. Fusion is real deal, real deal.
Obviously, I agree, sir. And I would argue, while in Washington we have spent time talking about fusion and convincing members that this is a key to our future, our private sector has not stopped. You have seen, even since our last conversation, you have seen investments, you have seen partnerships between state and local level with our key companies. Part of our fusion commission, we have talked to almost every fusion company, and they are there. They're doing remarkable jobs, different pathways towards that fusion energy outcome, but they're there and they're hopeful that this is the moment that we can press forward and invest, and so we can accelerate this. So how do you explain this duality? You visited some of these companies, I've seen. There's a massive energy behind these companies right now in terms of investments and partnerships and really making fusion breakthroughs.
It's hard to overstate the catalytic effect of artificial intelligence. We're early on in it. When I was at the Plasma Fusion Center in Princeton or any other facility, the impact of AI to replicating the center of the sun on Earth is hard. This is a very helpful tool scientifically to do that, but it's also been massively political catalytic. Every politician, every state around the world, energy went from one of the issues. People used to tell me, it's just one sector of the economy. We don't need to do that as much here. And my answer always was, it's not one sector of the economy, it's the sector of the economy that enables every other sector. Like energy's different. It's special because it makes everything else possible. Because of AI, that belief is widespread today. Everybody's excited about energy innovation, energy advancement in their state. It's bipartisan, it's across the country. This is helpful because again, it's a hard problem. We need that support. We need that welcoming business environment for fusion companies and building fusion research facilities. We need that support if state governments are going to lean in with matching funding on fusion. What message does that send to federal politicians? This matters. People believe in it. So I'm very optimistic. I just don't want to ever sound complacent. We need to all work together to help push this ball to massively step up United States government, federal government funding in fusion. I focus my efforts in the spring on AI because AI is transformative. And that sale, I think, was successful. Chike Fleshman, who you'll hear about from later today, has been a passionate guy on AI, on fusion, on all of these things. And you'll hear a little bit from him about how we get people excited about this. But again, the sell is there, the sell is real. Look at the people in this room who are top technologists, entrepreneurs, policy people. We are coming together to make fusion a reality. The other thing that's great for fusion is we have multiple approaches. We have magnetic confinement fusion, we have laser fusion, and we have another really electric or electromagnetic confinement fusion. Multiple pathways here. It is an exciting time.
Just to piggyback on the AI, sir, because last time we talked, which was late spring, you were obviously passionate about the AI trajectory where we're going. I asked you about the lab project that you have launched, Manhattan Project for AI. Can you tell us more where we are right now with that? How do you see this now evolving in the next couple of months?
Yeah, so my view of AI is it's just like this, like fusion, but it's just a little bit broader. It's this enabling tool that's going to make humans more powerful. Better at, making memes of turning people into claymation figures, so maybe not massively world-changing there, but AI can do so much. It's going to make our businesses more efficient, but the thing I'm particularly excited about is it's going to make scientific discovery move faster, and that's related to fusion and quantum. We're going to figure out, we need the human mind, the human creativity. It's just a supercharger for that. And fortunately, there's such huge commercial money in it that data centers right now are being developed everywhere people can get energy and permits. So we put out who wants to build on our national labs? We got a lot of land, we'll work with you to get quick permits. 300 responses. And one of the things I've said is we want people who would move fast. You don't need to tell the hyperscalers to move fast. We want to build, and we want some of your compute. So we're doing deals now where people are going to build large data centers and give maybe 20% of the compute out of that data center for our national labs to drive science forward. And of course, fusion's one of those big areas. And then I've also emphasized speed. We could have a new AI for science data center installed by the end of this year, entirely funded by private capital at one of our national labs. So I think businesses are ready to meet this challenge. They're not like, we're not arguing about little terms around the edges. They realize the time is urgent. We want to show the government can move fast and quick and lean in, and I think we're seeing that in the private sector as well. Again, first in AI, but we need that same effort, and I believe we will get it in fusion and in quantum.
We're getting close to the answer, but two last questions. Number one is, I know just fusion and quantum AI is not your preoccupation. You worry about other energy sources and resources we have and working with our allies. How do you assess our state of play in the energy space right now, globally? And then lastly, next 6 months, what would be your key priorities? We talked last spring. I understand now you're focused on fusion, quantum, and AI, but the next 6 months, what do you think are the key milestones ahead of you?
So again, I mentioned AI's catalytic role for people understanding how critical energy is. The Russia-Ukraine war did the same thing, right? And when I traveled through Europe and meet with people there, they had, I would say honestly, enfeebled their energy system Germany and the United Kingdom today produce meaningfully less energy than they did 20 years ago. 20% less energy. They've spent a ton of money on it, and they produce less at a higher unit price, which means their industry is left. And now they became dependent too much on Russia for their even supply of energy to run what they've got left. So that has been transformative as well. So in Europe, so the fastest growing energy source today by far is natural gas, right? So one of our pitches is US natural gas production is growing so fast, we can produce a crazy amount. It's just how much can we move with pipelines and LNG export infrastructure. But our goal is to displace all Russian gas in Europe as fast as possible. Because natural gas is much cheaper than oil, but you need infrastructure to move it. If Europe no longer imports any gas from Russia, they're not going to get the money from selling that gas. They got one pipeline that goes to China. They got a certain amount of LNG infrastructure. That's all the gas they can move. Their ability to sell gas is declining. Their ability to fund that war is declining. But when you go to Asia and you look around everywhere around the world, people want to be part of AI. They see the huge upside in it. But to enable that, you have to have reliable, dispatchable electricity, and people are game for finding that any way they can. And in the short run, that's dominantly natural gas. But it's also going to help a renaissance in fission. We got big atoms we split and heavy atoms we fuse. To me, they're both on this nuclear spectrum. I think we're going to see fission energy rise quickly. There's money and excitement going in that. Man, it is an awesome time to be in energy. We finally have an appreciation because the rich countries thought they'd solve the energy problem. It was all good. We don't need any more energy. We just want to produce it differently. That mindset has changed. If we want to change the world with AI, we need more energy. And that's opened the eyes that, well, maybe the rest of the world needs more energy too. So I think energy has come from one issue to a front and center issue. God bless President Trump. He's East Coast real estate developer, but he's always known instinctually energy matters. More is better. More produced from the United States is better. We can bring peace and prosperity by having more energy. So he is all in on this. Is President Trump going to be all in on fusion? Absolutely. In fact, you'll see announcements on this in the future. So I could not be more excited at the time. I thank everyone in this room who's working in AI, who's working in fusion, who's driving innovation. I thank my friend Ylli and the fabulous group he runs that's been all in. How do we figure out what are the big scientific issues? How do we mobilize people and motivate action and get smart people that are passionate? You're a meaningful driver of this effort as well. And I thank you for that. He visited me a few months ago and he said, what can we do? I said, we got to mobilize everyone on fusion. Of course, he knew plenty about fusion. But I said, we need up-to-date data on what's happening in the US, what's happening in China, where this could go, how do we do this kind of efforts? I've asked commercial businesses that same question, and everyone has stood up. You guys released a great report recently. DOE just released one as well. Look, we're gonna get the fusion ball moving. I think we will see more progress in the next 5 or 10 years, much more progress than in all of the history before on fusion. Everyone sitting in this room, we're finally going to see the reality of fusion come. First in the electricity grid, ultimately in industrial process heat to make things, and hopefully we can rapidly scale that up as we figure out the most efficient topography and technologies to harness fusion. But man, again, it is awesome, and I thank you for your help, and I thank everyone in this room for your help in making it happen.
Secretary Wright, thank you so much. What an incredible start of the day. Thank you for your service. Thank you for putting really national security, AI, and energy at the forefront. And as always, thank you for coming by our event. Truly appreciate it. Please join me in another round of applause for Secretary Wright.
Thank you. Thank you.